All right, so welcome everyone. My name is Kellen Green. I'm a senior software engineer here at Splunk for the past 6 years. A little bit about me. I'm primarily a web engineer. So I focus on front-end technologies like JavaScript and CSS, as well as some back-end languages like Python and Go. Now, today's agenda is pretty simple. Splunk is getting faster every year. However, this past year, Splunk got really fast. So I want to show you a few behind-the-scenes details for how we achieve this. And lastly, I want to arm you with the knowledge you need to take advantage of these improvements. So during Conf 2017, Splunk 6.5 was released. Since then, we've managed to decrease the time it takes to run a search by 58%. Meaning, if a search took a minute on Splunk 6.5, Splunk 7.1 would finish that same query in about 34 seconds. This data comes from our internal QA suite of around 80 searches. These vary in density, commands, and duration, so anything from a couple seconds to around 30 minutes. As you can see, we're getting very close to that 50% mark, so let's see if Splunk 7.2 has something to say about this. Quickly, just so we're all on the same page, I want to cover some terminology that goes into making up a search on Splunk. So firstly, our logs are generated and they're sent to the forwarder, at which point they get passed to the indexer. This then gets turned into buckets, which is Splunk's form of sharding. Afterwards, TSIDX files are generated. This is how Splunk will filter our results. So foo equals bar, you obviously just want foo, not all the results. And then lastly, a journal will be created, which will be the compressed version of our raw events. Sometime later, a search will be created on the client. This will get sent to the search head, at which point will get turned into what's called a Lispy query. This is Splunk's internal query language. This then gets passed to the indexer. At this point, it will use the bucket, the TSIDX, and the journal to fulfill your request. This gets bundled into what's called a result set, which is then sent back up to the search head, is turned into JSON, which is then sent back to your browser. Now, obviously, I glossed over a lot of details in that previous slide. So if you're curious to know any more about the Splunk search process, I gave a talk last year that goes over many of those details in depth. All right, improvement number 1, journal compression. Using the map from a couple slides ago, this will naturally reside within the journal. So as I mentioned earlier, raw events are compressed on disk within the journal. Today, Splunk defaults to the gzip compression algorithm, which offers decent overall performance and space savings. Several years ago, Splunk 6.3 added LZ4 compression as an option. This offered improved compression and decompression rates. However, this came at the cost of 30% larger journals. Since most of our data is being sent over the network from the indexer to the search head, this tended to nullify any performance benefits you were seeing, or you would have seen. So to rectify this, starting in Splunk 7.2, we're announcing support for the Z standard journal compression. This is a relatively new algorithm developed by Facebook in 2015. It offers 4x the compression rates and 3 times the decompression rates over gzip. However, unlike LZ4, it actually offers around a 5% space savings over gzip. So roughly we can think of Z standard as the best of both worlds. It has gzip space savings with LZ4 decompression rate speeds. All right, so let's see this in action. Using Splunk 7.2 with gzip journals, we have a simple retrieval of 100,000 events. So search index equals 100,000, pretty simple. And this is around a 20-second operation using under that instance. After enabling Z standard, that same operation drops to just 14 seconds. So same search as before, I've only enabled Z standard. So we see a respectable 30% search time reduction, but it's only a couple seconds, so we can probably do better. If we up our sample set to 1 million events, so search equals index 1 million, our gzipped instance now takes 190 seconds to complete, or a little over 3 minutes. Anybody venture to guess what Z standard can finish this in? Search party hangover? It's all right, no problem. It's now just 108 seconds, so shaving nearly a minute and a half off of our search time. So this raises our reduction up to 43%. And if we continue that up to 10 million events, we can actually see that gap continue to grow between the two algorithms, which makes sense, right? If the journals are smaller and easier to retrieve, the more times we need to do them, the faster our search will be waiting, we'll be left waiting for data. So that checks the box on performance, but what about size on disk? So using the 1 million event set from earlier, the size of our journals has actually dropped by 3%. Not quite the theoretical 5, but depending on your data, that's going to jump side to side. So nothing too earth-shattering. Savings are welcome. And once enabled, you'll actually start to see the new .zst file extension within your journals in the raw data folder of your indexers. And as I said, once enabled, sadly, zstandard didn't quite make it into 7.2 by default. However, this can be enabled on an index-by-index basis in your index.conf file within your apps. Note, this will only change the compression algorithm for newly created buckets. Splunk won't retroactively go back and recompress your old buckets. Which is fine because Splunk supports mixed searching across multiple compression algorithms.
Question about LZ4.
Yeah.
If I remember your earlier slides, it's still overall faster. It's just you need to take the disk space up.
It is technically faster. However, when you have to move larger data across the network, like for a single instance, yeah, it'll be faster. But if you have a search head and an indexer, that tends to get nullified because you're sending more data over the network. Over the network. But anyway, Z standard's here, so it doesn't matter anymore. All right, improvement number 2, data serialization. Back to our map. This improvement involves the data being sent between the indexers and the search head. So in our results bundle. So currently, indexers send search results to the search head via the CSV file format. CSV is pretty simple, and it's served us pretty well over the years. However, it does come with several limitations. For one, it's text-based, so everything needs to be converted to ASCII on disk. And 2, it's a pretty verbose encoding standard, meaning it needs extra commas, new lines, escape characters, and all those things in order to function. As we saw with Z standard, yes, this all gets compressed, but that's really just making our compressor do more work than it really needs to. So, starting in Splunk 7.2, we're doing away with the CSV data serialization altogether and introducing the search results serialization format, or SRS. This is a new in-house binary format, which aims to solve the previously mentioned limitations of CSV. All right, let's take a look at how we achieve this. In typical data sets, we often see values that repeat across many rows. So think of things like status equals 200 or method equals get. They're all over the place. With SRS, we're now able to declare rows that repeat across multiple columns. So using this data set here, if we look at the source type column, we see that it repeats 10 times as access log. With SRS, we can now simply represent this as 10 access log. We can also do the same for the other columns. This obviously has 2 benefits. One, our compression algorithm has to do much less work. And second, and most importantly, this requires way less I/O in order to create your data set. SRS can actually take this event deduplication one step further with string pooling. In string pooling, each unique string of data is placed into a lookup table, which can be referenced by our events. So again, back to the source type column. This can be rewritten as pointers to the table like so. And naturally, we can do the same across our other columns as well. Afterwards, we can then actually employ the row duplication technique from earlier. So on highly repetitive data, this is going to be a huge space savings. SRS brings another important feature to the table, field type retention. This means now integers, floats, and booleans all retain their type information after the journal extraction. Remember previously I mentioned that numbers would need to be converted to ASCII when using the CSV file format, and then converted back to a number onto code. This was particularly slow for floating point numbers, which will see the largest benefit under SRS. Not converting every number to ASCII will also have some additional space savings. For example, if a timestamp is converted into ASCII, it requires around 80 bits of storage on disk. Under SRS, that same number would now just take 40 bits using our variable length encoding. All right, SRS has one more trick up its sleeve. It's column major serialization. And what does that mean? Basically, this is a fancy way of saying that columns are able to be sent together over the network. Now, why would we want to do that? Well, let's say our search head is waiting to perform some post-processing on the path fields. With CSV, data is sent row by row, meaning we'd have to wait for the entire data set to be transmitted before we can start working on it. However, with SRS, that path column can be sent first, giving the search head the data it needs to complete your search faster, along with the other results as they come. The benefits for this are obviously, again, twofold. One, we can limit the time that Splunk spends waiting on data. And two, since columns are often similar data sets, those have compression benefits. If method equals go or method equals get is just over and over and over again, that's much easier to compress since there's no other data in the column. Should you be curious where you can find this new SRS format, they can be seen in the dispatch folder on your search head in a file called results.srs. I will note that since SRS is binary, it's not readily readable as the CSV format once was. To assist this, Splunk has added 2 new commands to Splunk D to aid you should you need to convert between these two data formats, Splunk D to CSV and Splunk D to SRS. All right, back to the fun stuff. So SRS will really excel in searches that can do many things in parallel. So I'm going to cheat just a little bit and use the stats command for these benchmarks. Using our 1 million event data from earlier, we're going to count the number of occurrences for a field with around 1,000 distinct values. With SRS disabled on Splunk 7.2, this is around 8 seconds. After enabling SRS, our time's cut in half by just over 4 seconds. So factoring in sub-second calculations, it's about a 51% decrease in search time. All right, same as before, 4 seconds isn't very impressive. So scaling up our same search by an order of magnitude, so 10 million results and 10,000 distinct values, this takes around 54 seconds to complete under CSV. And once we enable SRS, that drops to just 17 seconds, up to a 67% search time reduction. So marketing has told me that I can promise around a 10% reduction in search times when using SRS. However, in searches that are high cardinality, such as the ones we did with stats and t-stats, if you were so inclined, that number will grow much larger, since t-stats and stats are able to do things in parallel. And as we've seen, your performance will actually grow along with the size of your data set. So the more data it needs to extract, the better it's going to perform over gzip. And I have some more good news. Unlike zstandard, SRS is enabled by default starting in Splunk 7.2. So just an upgrade is all you'll need to take advantage of these new improvements. And if for some reason a search head had it disabled or an indexer had it disabled, SRS or Splunk will gracefully fall back to the CSV format. So you don't have to worry about everyone being enabled. It'll just fall back to CSV. All right, one more improvement. The metric store. Looking back to our map, this improvement is going to reside within the TSIDX files on our indexers. Now, the metric store is kind of new, so I'm going to do a quick overview. For those that don't know, the metric store came out at Conf last year as a new storage type. It was designed to leverage numerical and structured data to vastly improve the performance of your searches. But this came with a downside. You can only search using the imstats command, which is far more restrictive than the search command you're used to using. But for this sacrifice, the metric store gave you a 200x boost in performance. So in certain situations, this can be huge and very worth it. So this afternoon, I'm just going to be scratching the surface on the metric store. But if you're eager to learn more, some fellow Splunkers gave a talk earlier in the week, which goes much more in depth onto the metric store. So if you missed that, that recording will be available at conf.splunk.com shortly after the conference. All right. So Splunk uses what's called the TS-IDX file to narrow down your search queries. And for many years, this worked great. It was fast, flexible, and allowed us to do things like substring matching, so contains, those kind of queries, starts with. This came with one great limitation. TS-IDX was only really designed to operate on text, where numerical data, which is what metrics are, you don't need substring. You'll never check contains 747 within a number, most likely. So with metrics being inherently numeric, we knew that a new index format was going to be needed. So for Splunk 7.0, we introduced a new index format called MSIDX. This shipped with minor modifications to the existing TS-IDX data structure, and it got the job done, but going forward, we knew we could probably do better. So starting in Splunk 7.1 and wrapping up in 7.2, we rectified this with MSIDX v2. It was a major reworking of the data structure when using metrics searches. So every MSIDX file is composed of three parts. We have the lexicon, which is our filters. We have the postings, which is our pointers. And then the time series, which is our data, where our metrics are stored. To cover the differences and what changed, let's take a look at how each version would tackle a search. So say we're looking for the average temperatures of Orlando, which apparently is just humid. First, we do a binary search through the lexicon until we arrive at Orlando. This grants us our posting values, which we can then use to look up the metrics that we're interested in. While this works, there are inherently a couple flaws at play here. One, since our time series is just one large array, data that is like data is usually not co-located on disk, increasing the needs for our I/O. You can see the orange results that we're interested in probably aren't going to be in the same platter, so we'll have to do more seeks to find them. And two, each metric requires its own posting, so really it'll look like this. It looked fine with just 3 metrics, but you'll probably have several billion metrics, so that will explode the size of your TS-IDX file fairly quickly. So let's see how V2 can change that formula. Using the same search as before, we arrive at Orlando. However, this time, we're now only greeted with one posting. This is because with MSIDX v2, time series has been reworked, so now that each dimension is in its own array. This has space savings by cutting the number of required postings by a few order of magnitudes. And has the added byproduct of reducing our I/O needs, since now all similar dimensions are stored together. And we can actually see this space savings in our buckets. So using a 100 million metric, the disk usage for my benchmarks actually dropped by nearly half a gigabyte over MSIDX v1. So 20%, not too bad. But you probably didn't come for space savings, so let's get on with the benchmarks. So this search is a bit more complicated, so bear with me. So we have a metric store of 10 million events, which will be filtering down to just 1 million events. So I really want to hit that lexicon, since I know that it's going to be a bottleneck in MSIDX v1. And then finally, we're going to group by a field with 10,000 unique events. So under Splunk 7.0, this takes about 5 seconds to complete. And with Splunk 7.2, along with MSIDX v2, it's down to just under 2 seconds, 1.5, for a 68% drop in search times. And by now, you know the drill. Let's step it up a bit. So same search as before, but this time we're just going to add a 0 to everything. So 100 million events, 100 million metrics, that is. This search needs 36 seconds under MSIDX v1. It's now just 8. So 78% reduction in search time. And like SRS. This is also enabled by default from 7.1 onwards. This means that any newly ingested metrics will automatically be stored as V2, so you could already be using them now. Much like SRS and zstandard, Splunk also supports searching V1 and V2 data at the same time. It'll just handle it automatically for you. Lastly, I'd be remiss if I didn't mention the real heroes of today's presentation. I'm a software engineer, but I wrote 0 lines of code for any of these things. So, however, these people did. So if you know them or you see any of them in the halls before you leave, be sure to give them a high five. And thank you for attending. Appreciate you guys coming. Now, during the QA, I have a query we're going to run live, because there's nothing like a live demo to break. There we go. Okay. Let me get these fired off, and I'll start taking questions. All right, I'm going to give Splunk 7 a head start because it needs it. All right, there they go. So we have Splunk 7, just stock, nothing changed, and then Splunk 7.2 with SRS, zstandard, and MSIDX v2 running in one search. So we'll see. We'll see how this goes. And any questions while we wait? Yes, can you use the mic so it's on the recording, please? If you could. There's no audio on the computers. Oh, right. Well, then, never mind. Just shout, sir.
So it seemed like for SRS there was maybe a trade-off between CPU and I/O. So some of the performance was do more CPU calculations, so you have to do less I/O. Did that actually cause a significant shift in sort of the balancing of the, say, the existing systems you have? Things that were I/O bound now might actually be more CPU bound.
So SRS for sure uses less memory, since you no longer need to decode all those strings back and forth. CPU, I think, was kind of a wash. It probably uses more CPU in the creation of the file, but it has to do it, but it'll do it in less time. So I'd say it's probably a wash, although I don't know. If you'd like me to look, I can probably get that for you. Oh, yes? Nope, all right. How are we doing? Oh, looks like 7.2 already overtook it. Yep.
Is there any reason not to use the new compression format in production right away?
No, not really. I think in Splunk Next, or the next version that is, not the product. In the next release, I think it'll go to full production. It came in kind of late, it was like mid-August, and we kind of just ran out of time. So to be safe, we just said, let's ship it, not enable it, and go from there. Oh, it's already done. 151, and Splunk 7's at 44%. So as you can see, we did pretty good this last few years. So yeah, yeah, go ahead.
Yeah, so first of all, thanks. This is awesome. This is exactly what I wanted vendor to do. Just
Thank you.
Get better. I'll work on making cool stuff.
Thank you.
How steep do you think the curve is going forward? Like next year, you're going to go tell us again 50% better?
Ooh.
You're going off fruit, right? And I wonder how you feel about how low hanging. I'm not asking you to make a.
Yeah.
I'm asking you to make forward.
Yeah.
I just wonder how you feel about it.
we do want to enable SRS as an export format moving forward. So right now, that would improve data getting outside of Splunk. And then we also want to add Z standard compression in between. So right now, the journals are all compressed that way. Then start compressing all data for all events that way. So that'll certainly, once we figure out and say, yeah, all right, this is working as we want to see it, we'll start adding compression everywhere like that. Yeah, I would say the low-hanging fruit's probably been picked. MSIDX, I'd imagine there's going to be another iteration in the next major version that'll add some more stuff. But MSIDX and numerics, it's super fast. Like that, what was it, 100 million events took 30 seconds? Like that's pretty quick. Oh, it's done. Good job, Splunk 7. Almost. You're getting there. Yeah. So that's it. Well, oh, go ahead.
So sorry,
No?
Regarding metrics stuff. My gang tells me on the street they heard whispers of a rate command, which does the stream stats crap we do. Basically understating metrics to protect HH and all that.
Ooh, I don't. I'm not. To be honest, I had to learn all about metrics for this talk because they were new to even me. So when they announced V2, I was like, oh, I should probably learn V1. But yeah, is it done? What do you get? Oh, that's cute. 300 seconds. So about almost 50. I'm a little under. I lied. Sorry about that. Anyway, thank you for coming. I appreciate you guys being here. Hope you had a good conference.